Most of the time in real life, you have to be able to predict. You have to have a reason for dealing with problems. Chance just isn't really going to cut it. And so you need a system. You need to be systematic. Well, what is more predictable and calculable? What is more systematic than mathematics? I had a conversation with a programmer once, and when he heard that I was a math teacher, he offered his testimony and said, "Tell them that a programmer told you he uses math every single day." Now, it's not hard to find math everywhere in any particular field of study. Students are usually told math is art. So this type of sentence might indicate that means the value of math is in its beauty. Or maybe you've heard math teaches you logic and problem solving. And this then tells you that that is the real value. But what about just the general daily thinking applications? One way that you can think about this is that math is language. Now, maybe you've heard that before as well. But here's the idea. Where then is the value in language? It's in its vocabulary. In writing and communicating, we have words that are assigned to thoughts. Your brain thinks with quite the mathematical sophistication. So why do we use base 10? Well, because it developed and it became easy enough. Why? I have 10 fingers. Well, that's really handy and quick and easy. So the reference of the numbers from 1 up to 10, all of those symbols are much more easily comprehended than having to talk to each other in binary in terms of quantity. So here's an example. Think about the idea of quantity. Some languages, they actually only have a word for 1, 2, and many. They just never got around to subdividing the word many into more particular parts. You've probably subdivided many before. You have probably heard of 1, 2, 3, 4, and so on. So here's some different ways that we have refined some vocabulary for quantities. One example is number words, calling something 1, 2. There are words that indicate those ideas. Tick marks, which indicate ways of counting and quantifying things, specifically by fives. We even have some shortcuts. Roman numerals. We even have a shortcut for emptiness. The position of a symbol is another shortcut. For example, the 2 in this position actually represents 20, not 2. The 1 actually represents 100, not just 1. Numbers themselves can even be subdivided. For example, 3 can be made up of 1.5 and 1.5. So we have fractions and decimals, different subdivisions. Numbers can even be negative, indicating that they would go in a different direction as opposed to the other main direction, the positive direction. Math is filled with vocabulary that represents very specific ideas. Here are some other applications of this vocabulary. Structure. What might we call something that deals with structure? We typically call that type of system algebra. There are different types of algebras. What about dealing with shapes? Geometry, we call that. What about dealing with change? That's calculus. We even have something that deals with chance. Stats and probability. So why would you learn to write something in slope-intercept form? It would help you see and make predictions of business. Maybe business is rising due to some variable. Maybe it's actually falling. How do you know? Because of using a simple tool like this general equation. So where do you see certain skills or careers in math? Well, math helps you in your logic skills, in analyzing. It helps you in problem solving, in reasoning, helps you develop precision and accuracy. It can even help your time management. What are some careers? I won't write these out, but some careers in math are accountants, actuaries, computer programmers, doctors, engineers, investment managers, lawyers, government research, theoretical mathematicians, numerical analysts, market researchers, systems analysts, banking, anything dealing with space and the aircraft industry, economists, financial analysts, dealing with marketing, being a claims examiner, an investment manager. I think I said that already. International trade specialist, a real estate investor, a statistician, or you could be a teacher. There are even more applications. If you think of art, what is it that makes a piece of art attractive? Well, you could study that pattern that makes pieces of art attractive, and then make the correlation, and then replicate the pattern to get better at creating even your own art. Suddenly, math just helped you be a better artist. A lot of people think if you are smart, then you will do mathematics. But the truth is, you don't have to be smart to do math. But if you choose to do math, it will help you to become smart. It builds your brain. It's like weight training, building muscles. Mental discipline, clear thinking, that's a requirement for intellect. Mathematics is all about connecting the patterns. The concrete and abstract thinking that's required by math will build your brain network. It will build the paths between neurons, the way you think, which then helps you in every other area of life where you're thinking. Once you begin making those connections, you can use those connections to make even more connections. And that then helps your growth, your knowledge, your learning, your understanding to make exponential progress.